Tonight, we journey backward through time, not to the beginning of humanity, for that story stretches across hundreds of thousands of years, but to the beginning of astronomy, to the moment when watching the sky became recording the sky, when noticing patterns became preserving patterns, when the first human scratched a mark on bone to remember what the moon had done, and in doing so, created the first calendar, the first scientific record, the first attempt to make cosmic knowledge permanent. This is not a simple story of discovery, not a triumphant narrative of humans conquering ignorance through reason. The birth of astronomy brought wonder and achievement, but it also brought questions we still cannot answer. Why did Neolithic peoples invest such extraordinary effort aligning massive stones to celestial events? What did Bronze Age cultures know that we have forgotten? How did civilizations without writing preserve astronomical knowledge across generations with such precision that their calculations still work today? We will explore 12 sacred moments in astronomy's emergence, 12 places where humans gathered to watch the sky and built monuments to what they saw, 12 mysteries that modern science has partially illuminated but cannot fully explain. We will descend into painted caves where stars appear in prehistoric darkness. We'll stand among megaliths aligned to solstices. We'll trace the paths of ancient astronomers who measured the Earth, predicted eclipses, built mechanical computers from bronze. The journey begins in Lascaux, where Paleolithic painters may have recorded constellations alongside their famous animals, continues to bone calendars carved 30,000 years before Sumer, follows the evolution of Stonehenge across 15 centuries of astronomical refinement, descends to Nazca's desert lines that only sky-dwelling gods could read, enters Maya temples that capture equinox light in serpent shadow, crosses to Australia, where the longest continuous astronomical tradition watches darkness between stars. We will examine the Nibra sky disk, a Bronze Age cosmos preserved in gold and bronze. We'll stand in Alexandria, where Eratosthenes measured Earth's circumference using only shadow and geometry. We'll marvel at the Antikythera mechanism, a computer that should not exist, complexity that would not be matched for over 1,000 years. We'll walk the windswept Orkney Islands, where stone circles older than the pyramids still mark celestial events with precision. We will follow Inca priests who believed they were tying the sun to earth, preventing cosmic wandering through ritual observation. We'll enter Egyptian tombs where star maps painted on ceilings guided the dead through eternal night. We'll sit with the accumulated weight of what ancient peoples achieved and what we have lost, what they understood and what we cannot recover. Tonight, we move slowly through these astronomical mysteries. We'll not rush. We'll allow the stars to emerge naturally as night deepens. We'll permit wonder without demanding explanation. We'll honor what ancient astronomers accomplished while acknowledging how much of their knowledge remains inaccessible to us, despite all our instruments and equations. So let us begin. Let the evening settle around us like a familiar darkness, and somewhere in the space between the first star watchers and ourselves, between bone calendars and digital observatories, between what was counted and what was understood, the story of humanity's oldest science waits, patient, precise, forever marked in stone and bone and bronze. Now, let us enter the cave where stars were painted in darkness, where the sky was brought underground, where the first astronomers left their testimony on walls that have kept their secrets for 17,000 years. In the darkness, beneath the Dordogne hills of southern France, where the Vézère River has carved valleys through limestone for millions of years, there exists a chamber that has held its breath since the Ice Age ended. The cave at Lascaux was sealed by a landslide, perhaps 15,000 years ago, and when four teenagers and a dog stumbled upon its entrance in September of 940, they discovered what would be called the Sistine Chapel of prehistory. The paintings that cover its walls, horses galloping, bulls charging, deer swimming, bison turning to look at something we cannot see, have drawn pilgrims and scholars for generations. But there is something else in Lascaux, something that most visitors overlook, something that suggests the painters were not only artists, but astronomers. Above the shoulder of the great bull in the Hall of Bulls, there is a pattern of dots, six prominent marks arranged in a cluster that mirrors almost exactly the configuration of the Pleiades, the seven sisters, as they would have appeared in the night sky 17,000 years ago. The seventh dot, fainter than the others, corresponds to the seventh star of the Pleiades, which is indeed dimmer than its companions. The alignment is too precise to be coincidence. The pattern is too recognizable to be random, and the placement above the bull, in a position that echoes where the Pleiades appear near the constellation Taurus, suggests that Paleolithic painters were recording not just animals, but the stars that rose with them. The implications settle slowly, like dust in torchlight. If the Lascaux painters recorded the Pleiades, then they were astronomers before any civilization we name existed. They watched the sky with enough attention to notice which stars clustered together. They understood that certain patterns returned with the seasons. They developed the symbolic thinking necessary to represent celestial objects as marks on stone. And they chose to bring the sky underground, to preserve it in a chamber where no actual stars could shine. Why bring stars into darkness? The question haunts the cave. These painters could have recorded the Pleiades on any surface, could have scratched them onto outdoor rock faces where the actual stars would have been visible for comparison. Instead, they placed their star map deep in a cavern that required torches to navigate, that demanded crawling through narrow passages, that was so difficult to access that the painting survived intact for millennia. The placement was deliberate. The darkness was essential. Something about the relationship between stars and sacred underground space matter to them in ways we can only approximate through imagination. The Lascaux star pattern is not alone. Similar dot clusters appear in caves across Europe. In the cave of El Castillo in Spain, a panel of red dots dated to at least 40,000 years ago may represent the constellation we call the Northern Crown. In the cave of La Tête du Lion in France, a pattern above a painted horse appears to correspond to the stars of Orion's belt. The consistency across sites and across millennia suggests that Paleolithic peoples shared astronomical knowledge, transmitted it through generations, developed traditions of star mapping that preceded written language by tens of thousands of years. But we must hold our conclusions gently. The cave paintings resist certain interpretation. The dots that seem like stars to us might have meant something entirely different to their makers. The patterns we recognize might be coincidental arrangements that our pattern seeking minds transform into constellations because we cannot help seeing what we expect to see. The evidence is suggestive but not conclusive. The mystery remains mysterious. What is certain is that the painters paid extraordinary attention to the world around them. The animals in Lascaux are rendered with anatomical precision that modern zoologists admire. The way a horse's winter coat differs from its summer coat, the way a bison's muscles move beneath its skin, the way a deer holds its head when crossing water. These were people who observed carefully, who noticed details, who possessed the patience to watch and remember and record. Such observers would have watched the sky with equal attention, would have noticed that certain stars appeared at certain times, would have understood that the patterns above them were as worthy of preservation as the patterns around them. We linger in the imagined torchlight, watching shadows move across painted surfaces. The cave was not empty chamber, but active sanctuary, visited and revisited across generations. Some scholars believe the paintings were created over thousands of years, each generation adding to what came before, maintaining the sacred space with fresh images and renewed attention. If so, the astronomical knowledge encoded in the dots would have been transmitted alongside the artistic techniques, would have been taught by elders to young painters who learned not only how to depict animals, but how to record the stars that marked their seasons. The cave preserved what open air could not. The constant temperature, the absence of light, the protection from wind and rain, and the erosion of passing time all combined to maintain images that would have vanished anywhere else. The painters may have understood this, may have chosen the cave specifically because it would protect their records, may have recognized that the darkness they entered with their torches would eventually become the darkness that preserved their work for descendants they could not imagine. We close standing in that imagined darkness, torch guttering, stars now eternal on stone. The last painter stepped back from the completed panel 17,000 years ago. Perhaps they sang or prayed. Perhaps they touched the marks with reverent fingers. Perhaps They simply left, climbing back through passages to a world where actual stars were rising, where the Pleiades were appearing above the eastern horizon, where the bull constellation was ascending exactly as they had recorded it in the cave below. What they knew, we cannot recover. What they saw in the patterns above them, what stories they told, what meanings they ascribed, what connections they felt between starlight and animal spirit and sacred darkness, all this is lost to us. The dots remain, the arrangement persists, and in the silence of the cave, the first known star map waits for eyes that may never fully understand what it was meant to teach. The chamber where stars were born before the sky, where darkness held what light would have destroyed, where the first astronomers left their testimony in the language of mark and position, forever preserved, forever partially incomprehensible, forever the beginning of humanity's oldest science. 30,000 years before the first cities rose in Mesopotamia, before any civilization we might name existed, before writing transformed breath into permanence, someone in the Dordogne Valley of France held a piece of eagle bone and began to make marks, not random scratches, not idle decoration, but deliberate notches, counted and spaced with intention that still speaks across the vast silence of millennia. 29 marks. Then a slight gap or change in pattern. Then 29 marks again. The Blanchard bone, discovered in the Abri Blanchard rock shelter in 1911, may be humanity's oldest known calendar, a lunar counter created by hands that left no other testimony of their existence. The significance settles slowly, like moonlight filling a valley. 29.5 days is the length of a lunar month, the time from new moon to new moon, from darkness to darkness, through all the phases of waxing and waning. The bone's notches correspond to this cycle with precision that cannot be coincidental. Someone watched the moon. Someone counted its transformations. Someone developed a system for recording what they observed so that the knowledge could be preserved beyond the limits of memory. In that act of marking, something fundamental changed. Astronomy began not as theory, but as practice, not as abstraction, but as the simple discipline of watching and remembering and recording. The Blanchard bone is not alone in its antiquity. The Lebombo bone, discovered in the border cave between South Africa and Swaziland, bears 29 notches and dates to approximately 43,000 years ago, making it potentially even older than the Blanchard artifact. The Ishango bone, from the Democratic Republic of Congo, dating to perhaps 20,000 years ago, contains multiple series of notches that some scholars interpret as a 6-month lunar calendar, others as a mathematical table, others as nothing more than a tool for scratching marks. The bones speak, but they speak in a language we cannot fully translate. What we can say with confidence is that the impulse to record time preceded civilization by epochs, that the astronomical drive, the need to understand patterns in the sky, to predict what would come, to feel less vulnerable to cosmic uncertainty, was not a product of culture, but was something that made culture possible. The bone calendars suggest that nomadic peoples moving across Ice Age landscapes carried astronomical knowledge with them, tracked the moon's phases for reasons we can only guess at, developed traditions of observation and recording that would eventually evolve into the sophisticated astronomies of Babylon and Egypt and Greece. But why track the moon? The question opens onto speculation that cannot be definitively answered. Perhaps the lunar cycle helped coordinate group activities, gathering at new moon, hunting during the bright nights of full moon, timing migrations to celestial rhythms. Perhaps the moon provided the first predictable pattern in an unpredictable world, offering comfort through regularity, demonstrating that darkness always gave way to returning light. Perhaps, and here we enter territory that some scholars find compelling and others dismiss. Women were the first astronomers, tracking lunar cycles that mirrored their own bodies, finding in the moon a cosmic reflection of earthly rhythm, developing calendrical knowledge that would have been practically useful and spiritually meaningful. The possibility that women created the first calendars deserves careful consideration. Menstrual cycles average 29 days, nearly identical to the lunar month. The correspondence is striking enough that cultures around the world have associated menstruation with the moon, have used the same words for both, have understood women's bodies as participating in cosmic rhythm. If women were tracking their cycles for practical purposes, predicting fertility, coordinating childcare, managing the demands of nomadic life, they would have naturally noticed the moon's parallel rhythm, would have developed notation systems to record both, would have created the first calendars from the intersection of bodily and celestial observation. We cannot prove this hypothesis. The bones themselves carry no evidence of who made them. The anonymous hands that carved the notches left no other record of their identity or purpose. But the possibility enriches our understanding, suggests that astronomy's origins may have been more diverse, more practical, more connected to women's lives than the conventional narrative of male priests and kings watching the sky for omens and power. The bones allow for multiple stories, hold space for interpretations we cannot verify but also cannot dismiss. The bone calendars also reveal something profound about human cognition. To create a lunar calendar, one must develop what cognitive scientists call external symbolic storage, the ability to record information outside the brain, to use marks on objects as extensions of memory, to create technologies of thought that allow knowledge to accumulate beyond individual lifespan. The notches on the Blanchard bone are not mere marks. They are proof that humans had developed the cognitive architecture that would eventually produce writing, mathematics, science itself. The bone is a step on the path that leads to the Rosetta Stone, to Euclid's Elements, to the equations that describe the cosmos. The first step the step that made all others possible. We sit in the quiet of imagined Ice Age night, watching the moon rise over landscapes we cannot fully reconstruct. The people who carved these bones saw the same moon we see, the same phases, the same face, always turned toward Earth, the same 29-day cycle that has governed tides and calendars and countless human activities for as long as humans have watched the sky. The continuity is moving. Across 30,000 years, the moon has been constant. Our watching of it has been constant. Our need to understand it, to record it, to feel connected to patterns larger than ourselves, this too has been constant. The chapter rests in the silence of not knowing who held these bones, who made these marks, what words they spoke as they counted. The moon continues its cycle. The bones rest in museums, and somewhere in the space between what was recorded and what was understood, the first calendar waits, patient, ancient, speaking in notches that predate every word we have ever written, the bone that counted moons, the marks that created time, the first calendar carved in eagle bone, testimony to humanity's oldest and deepest need to understand the patterns of the cosmos and to preserve that understanding for generations yet unborn, forever counting, forever silent, forever the foundation upon which all later astronomy would be built. On the Salisbury Plain of southern England, where wind moves ceaselessly across chalk grasslands and the horizon stretches unbroken in all directions, massive stones rise against the sky in patterns that have puzzled and inspired for centuries. Stonehenge is perhaps the most famous prehistoric monument in the world, a ring of standing stones, some weighing 25 tons, arranged with precision that speaks of astronomical knowledge, ritual purpose, and organizational capability that seems impossible for Neolithic peoples to have possessed. But Stonehenge did not appear suddenly. It evolved across 1,500 years, each generation adding to what came before, refining the monument's relationship with the sky until it became the astronomical instrument whose ruins we can still visit today. The earliest phase of Stonehenge, constructed around 3100 BC, was simple: a circular ditch and bank, approximately 330 feet in diameter, with an entrance oriented toward the northeast, toward the direction where the midsummer sun rises. Inside the bank, a ring of 56 pits, now called the Aubrey Holes after their 17th century discoverer, may have held wooden posts that marked some astronomical purpose we cannot fully reconstruct. The cremated remains of people were deposited in these holes, suggesting that from the beginning, Stonehenge was a place where astronomical observation and death ritual intersected, where watching the sky and honoring the dead were understood as related activities. For several centuries, Stonehenge remained in the simpler form. Then, around 2500 BCE, something remarkable happened. People began transporting bluestones from the Preseli Hills of Wales. a distance of approximately 150 miles to the Salisbury Plain. The bluestones are not enormous, ranging from 2 to 5 tons each, but transporting them across rivers, through forests, over hills, using only human labor, wooden rollers, and perhaps boats on water routes, represents an effort so sustained and organized that it suggests the stones themselves possessed significance that justified extraordinary cost. Some scholars theorize the blue stones were believed to have healing properties. Others suggest they came from an earlier sacred site that was being relocated to Stonehenge. Others propose that the specific stone from that specific place carried meaning now lost to us. The journey of the bluestones remains mysterious, testimony to purpose we cannot fully recover. The bluestones were arranged and rearranged. Then, around 2400 BCE, the massive sarsen stones were brought from Marlborough Downs, approximately 20 miles to the north. These are the iconic stones of Stonehenge, the huge uprights supporting horizontal lintels in a post and lintel arrangement that required precisely shaped stones and sophisticated engineering. Some sarsens weigh over 25 tons. Moving them, shaping them, erecting them, fitting the lintels into place with mortise and tenon joints carved from solid stone. The project demanded thousands of workers over decades of sustained effort. The result was an astronomical instrument of remarkable precision. At summer solstice, the sun rises directly above the heelstone when viewed from the center of the monument, sending light through the great trilithon to illuminate the altar stone. At winter solstice, the sunset aligns through the central gap in precisely opposite direction. The alignments are not approximate, they are not suggestive, they are exact, calculated and constructed by people who understood the sun's annual journey with accuracy that allowed them to predict its extreme positions and build monuments to capture the moments when the sun turned back from its wandering. But what did the alignments mean? This question opens onto mystery we cannot resolve. Was Stonehenge a temple where solstices were celebrated with rituals whose nature we can only imagine? Was it an astronomical calculator, allowing priests to predict not only solstices, but eclipses, lunar standstills, other celestial events? Was it a site of healing, drawing people from across Britain who believed that the power concentrated here could cure what ordinary medicine could not? Was it a gathering place for peoples who shared astronomical knowledge, who came together at solstice to confirm their calculations and maintain their calendrical traditions? The evidence supports multiple interpretations and excludes none definitively. The cremated remains speak of death and memory. Over several centuries, people were brought to Stonehenge to be buried. At least 63 cremation deposits have been identified. Perhaps many more remain undiscovered. The deceased were brought from across Britain. Isotope analysis of their bones reveals origins in Wales, in Scotland, in distant regions of the island. Stonehenge drew people not only in life but in death, was necropolis as well as observatory. place where the eternal rhythms of the sun intersected with the eternal silence of the dead. The connection between astronomy and death haunts the monument, the suggestion that people who watch the sun's annual death and rebirth at solstice found comfort in believing that human death, too, might be followed by return, by continuation, by participation in cycles larger than individual mortality. The monument fell into disuse. The blue stones were rearranged, perhaps multiple times. At some point, construction ceased. The centuries passed, and Stonehenge became ruin, became mystery, became object of speculation and legend. Medieval people believed it was built by giants or by the wizard Merlin. 17th century antiquarians began the scientific study that continues today. Each generation has brought new questions and new tools, has peeled back layers of mystery while adding new puzzles, has understood Stonehenge more precisely while acknowledging how much remains unknown. We stand in the imagined midsummer dawn, watching light touch the heelstone, watching shadow and brightness play across the sarsen surfaces as they have played for 4,000 summers. The builders are gone. Their words are lost. Their understanding of what they created cannot be fully recovered. But the alignments remain accurate. The calculation persists. And in the moment when solstice light enters the monument, exactly as it was designed to enter, something of the builder's intention survives, communicated not through language, but through geometry, through the relationship between stone and sun that speaks across millennia, the circle that swallowed the sun, that held light in place through careful calculation, that watched solstices and guarded the dead and served purposes we can never fully comprehend. Stonehenge, forever aligned to the sun's turning, forever mysterious, forever testimony to people who understood the sky well enough to build monuments that would capture its rhythms for generations they could not imagine. In the coastal desert of southern Peru, where rain falls perhaps twice in a decade, where the land has remained essentially unchanged for thousands of years, lines stretch across the plateau like messages written in a language we cannot read. The Nazca lines, hundreds of figures etched into the earth by removing the reddish pebbles of the desert surface to reveal the lighter ground beneath, depict animals, plants, geometric shapes, and mysterious patterns so vast that they can only be comprehended from above. A hummingbird 300 feet long, a spider with legs extending 150 feet, a monkey with a spiraling tail, a condor with wingspan stretching 400 feet, shapes so large that the people who made them could never have seen them whole. The mystery of purpose settles over the desert like heat shimmer. The Nazca lines were created between 500 BCE and 500 CE by the Nazca culture, people who left no written records, whose understanding of what they were making cannot be recovered from any text. The lines were built by removing surface stones and piling them along the edges, creating negative images that have survived because the desert receives almost no rain to erode them and almost no wind strong enough to disturb them. The effort was substantial but not impossible. Calculations suggest that a single line might have been created by a small group working for several days, that the entire corpus of lines could have been produced by sustained community effort over the centuries of Nazca civilization. But why make images that could not be seen? The question has generated theories ranging from the astronomical to the religious to the extraterrestrial, though this last category says more about modern imagination than about ancient Nazca. The astronomical theories note that some lines point toward solstice, sunrise, or sunset, toward the rising points of prominent stars, toward positions that would have been meaningful to people who watch the sky for agricultural and ceremonial purposes. But only some lines show astronomical alignment. Others point toward seemingly random directions. The astronomical explanation accounts for part of the phenomenon, but not its entirety. The religious theories propose that the lines were ceremonial pathways, that people walked them in procession, that the act of moving along the line was the ritual, that the image was less important than the journey. This explanation finds support in the width of many lines, which would accommodate walking, and in the presence of pottery fragments and other offerings found along some pathways. The lines may have connected sacred sites, may have guided pilgrims through the desert landscape, may have been paths walked in prayer or celebration whose meaning was in the walking itself, not in the completed image that no walker could perceive. Perhaps the gods could see. Perhaps the Nazca believed that celestial beings looked down from above, that the sky was populated by spirits who could perceive what humans could not, that the lines were offerings to those elevated observers, communications in a visual language meant for eyes that dwelt among the stars. The monkey and the spider and the hummingbird may have been totemic animals, may have represented clans or deities, may have been prayers made permanent in the desert floor. The geometric shapes, the spirals and rectangles and zigzag lines, may have encoded information we cannot recover, may have been calendars or territorial markers or something our categories cannot contain. The water hypothesis deserves consideration. The Nazca Desert is one of the driest places on Earth, and water was the Nazca people's most precious resource. Many lines point toward the Andes, toward the mountains where water originated. Some lines seem to connect to puquillos, underground aqueducts that carried water beneath the desert surface. The lines may have been part of a water cult, may have been prayers for rain, may have been ceremonial connections between the desert people and the distant mountains where their survival depended. The monkey with its spiraling tail may represent water, the life-giving resource that spirals and flows. We walk the imagined lines at twilight, following paths that stretch beyond sight, trusting the pattern we cannot perceive. The Nazca people who created these lines would have walked them similarly, knowing they were part of something larger, something that made sense from a perspective they could not achieve, something that connected them to sky and mountain and water and the sacred animals whose forms they carved into the earth. The walking was the purpose. The participation was the meaning. The completion was less important than the continuation. The lines remain. The desert preserves them. And modern viewers, looking down from aircraft or from satellite images, can finally see what the Nazca could never see: the completed images, the vast extent of the geoglyphs, the desert transformed into canvas for sacred art. But seeing the image is not understanding it. We can perceive what the Nazca created while remaining unable to comprehend what it meant to them. The lines speak in visual language we do not understand. The messages they carry cannot be decoded without the culture that encoded them. The desert keeps its secrets while revealing its monuments. We close as night falls over the Nazca Plateau, as stars emerge above the lines that cannot be seen in darkness. The Nazca astronomers may have watched these same stars, may have aligned some of their lines to celestial events, may have understood connections between sky and earth that we have not yet discovered. The lines wait in the darkness, the desert holds its breath, and somewhere between what was made and what was meant, the Nazca legacy remains, patient, cryptic, speaking in a language of line and shape that we are still learning to read. The desert lines that only gods could see, that humans walked without perceiving, that the earth has preserved for 2,000 years. Nazca, forever mysterious, forever testimony to human need to communicate with the sacred, even when, especially when we cannot see whether our messages are received. In the northern lowlands of the Yucatan Peninsula, where jungle once covered pyramids and time measured itself in cycles within cycles, the Temple of Kukulkan rises above the ancient city of Chichen Itza. 4 stairways of 91 steps each, plus the platform at the summit, create 365 stairs, one for each day of the solar year. 9 terraced levels on each face, divided by the stairways, create 18 sections, one for each month of the Maya calendar. The numbers are not coincidental. The architecture is calculation. The temple is a calendar made of stone. But the most remarkable phenomenon occurs twice each year, on the spring and autumn equinoxes. As the afternoon sun descends toward the horizon, triangular shadows begin to appear along the northern balustrade of the stairway. 7 triangles of shadow, created by the temple's 9 terraces, connect with the great stone serpent head carved at the stairway's base. The effect is unmistakable. A serpent of light and shadow descends from the temple's summit to the earth below. Kukulkan, the feathered serpent god, returns to his people, made manifest through architecture and astronomy and the precise calculation of solar angles. The phenomenon lasts approximately 45 minutes. Thousands of modern visitors gather to witness it, cameras raised, watching shadows move with the sun as they have built for over 1,000 years. The Maya architects who designed this effect could not have stumbled upon it accidentally. The angles are too precise, the shadow falls too perfectly, the serpent emerges too clearly. This was intentional design, astronomical knowledge applied to religious architecture, calculation that required understanding of the equinox, the sun's angle, the relationship between building geometry and celestial movement. The Maya astronomical tradition was among the most sophisticated in the pre modern world. Without telescopes, without metal tools, without contact with old world civilizations, the Maya developed mathematical systems that included the concept of zero, an intellectual achievement that escaped the Greeks and Romans. They tracked the cycles of Venus with accuracy that rivals modern calculations, predicting the planet's appearance as morning star and evening star across periods of hundreds of years. They developed multiple interlocking calendars: the 260-day sacred calendar, the 365-day solar calendar, the long count that measured time across thousands of years, creating systems complex enough to track celestial events across generations. The Dresden Codex, one of the few Maya books to survive Spanish destruction, contains astronomical tables of extraordinary precision, Venus tables that predict the planet's cycles for over 100 years, eclipse tables that allowed Maya priests to forecast when the sun would be devoured by darkness, lunar tables tracking the moon's phases across decades. The codex is damaged, is incomplete, represents only a fragment of what Maya astronomers knew. But even this fragment reveals sophistication that European scholars did not match until centuries later. Why did astronomy matter so much to the Maya? The question leads to understanding that Maya civilization made no distinction between astronomy and religion, between observing the sky and worshiping the gods. The celestial bodies were not merely objects to be studied, but were deities whose movements determined the proper time for planting, for warfare, for coronation, for sacrifice. The astronomer priests who watched the sky were not scientists in our sense, but were intermediaries between human and divine realms, responsible for understanding celestial patterns so that human activities could align with cosmic rhythms. The calendar was not merely a way of counting days, but was a way of understanding the character of each day, its sacred quality, its propensity for success or failure, its connection to gods whose influence waxed and waned with celestial cycles. To know the calendar was to know when to act and when to wait, when the gods favored human endeavors and when they demanded restraint. The astronomical knowledge encoded in temples like Kukulkan was not abstract information, but was practical guidance for living in harmony with the cosmos. The decline of Maya civilization in the 9th century CE remains partially mysterious. Cities in the southern lowlands were abandoned. Populations declined dramatically. Construction ceased. The astronomical traditions continued in northern cities like Chichen Itza, but the civilization that had produced such sophisticated knowledge was fundamentally transformed. Climate change, drought, warfare, political collapse all likely contributed. The cities fell silent, were reclaimed by jungle, waited for centuries before archaeologists began the work of recovery that continues today. Spanish conquest brought destruction and also paradoxically, preservation. The Spanish burned Maya books as works of the devil. Only four survive of the thousands that must have existed. But Spanish friars also recorded Maya knowledge, interviewed Maya informants, preserved information that would otherwise have been lost. The Dresden Codex survived because it was sent to Europe as a curiosity. Maya astronomical knowledge exists today because some fragments escaped the general destruction, because some information was recorded before it disappeared, because the stone inscriptions that the Spanish could not burn preserved calendrical data that modern scholars can still decode. We close as the equinox sun descends, as the serpent shadow completes its journey from temple summit to earth. As Kukulkan touches the ground he was designed to touch 1,000 years ago. The architects who calculated these angles are gone. The priests who watched the phenomenon are gone. The civilization that built this temple has transformed beyond recognition, but the temple still works. The calculation remains precise, and in the play of light and shadow, something of Maya astronomical knowledge survives, speaking in the universal language of geometry to anyone patient enough to watch. The temple that captured the serpent in shadow, that made astronomical calculation visible as divine presence, that demonstrated what Maya astronomers knew about the relationship between earth and sky. Kukulkan, forever descending at equinox, forever testimony to a civilization that watched the heavens with attention we are still learning to appreciate. In the Australian outback, far from the light pollution that dims modern skies, the night blazes with more stars than most contemporary eyes have ever seen. The Milky Way stretches overhead like a river of light, its dark lanes and bright patches creating patterns that have been watched for longer than any other continuous astronomical tradition on Earth, for at least 60,000 years, perhaps longer. Aboriginal Australia have observed the sky, tracked celestial events, incorporated astronomical knowledge into their cultures in ways that European settlers dismissed as primitive, but that modern researchers are only now beginning to recognize as sophisticated. The emu in the sky is perhaps the most striking example of Aboriginal astronomical thought. It is not a constellation in the Western sense, not a pattern made of bright stars connected by imagined lines. Instead, it is a figure made of darkness, of the dark nebulae that block the light of the Milky Way's background stars. The emu's head is the Coalsack Nebula near the Southern Cross. Its neck stretches along the dark lane of the Milky Way. Its body and legs extend across the sky. visible only when one learns to see absence as presence, darkness as figure. The emu's position in the sky changes with the seasons. In autumn, when it appears upright after sunset, it corresponds to the time when real emus are laying their eggs, signaling to Aboriginal people that eggs are available for gathering. In spring, the celestial emu appears diving toward the horizon, corresponding to the time when real emus are running. When hunting becomes the appropriate activity, the astronomical emu is calendar, is ecological guide, is practical knowledge, encoded in celestial observation. To watch the sky was to know when to gather and when to hunt, when to move and when to stay. But the emu is only one figure in a sky full of meaning. Aboriginal astronomy includes hundreds of star figures, constellations, and celestial bodies, each carrying stories, ecological knowledge, and moral teaching. The Pleiades appear in many Aboriginal cultures as a group of women, sometimes young girls fleeing an unwanted suitor, sometimes ancestral beings whose stories encode knowledge about proper social relationships. Orion's belt appears as three young men, fishermen in some traditions, hunters in others, whose positions and companions carry meaning specific to each Aboriginal nation. The sophistication extends beyond star figures to precise astronomical observation. Some Aboriginal groups tracked the phases of the moon with counting systems. Others observed the twinkling of stars, understanding that bright, steady stars were closer, while dim, twinkling stars were farther. An insight that Western astronomy did not confirm until the 20th century. Some tracked the variable star Betelgeuse, noting its changes in brightness, incorporating these changes into stories about an ancestor who became old and weak. The observations were accurate. The interpretations were cultural. But the watching was constant, generation after generation, for longer than any other astronomical tradition survived. The song lines that cross the Australian continent encode astronomical as well as geographical knowledge. These dreaming tracks, paths that ancestral beings traveled during the creation time, can be navigated through songs that describe both land features and sky positions. A traveler following a song line knows which stars to watch, which celestial events mark stages of the journey, which astronomical observations confirm that they are on the correct path. The land and sky mirror each other. What happens above happens below. The astronomy is embedded in geography, in story, in living cultural practice. Colonial encounter nearly destroyed this knowledge. European settlers dismissed Aboriginal culture as primitive, removed children from families, prohibited traditional practices, disrupted the transmission of knowledge that had continued for thousands of generations. Much was lost. Much more was hidden, protected by Aboriginal people who maintained their traditions despite persecution, who passed knowledge to children in secret, who preserved what they could against forces that sought to erase their culture entirely. Recovery continues. Aboriginal elders work with astronomers to document traditional knowledge before it disappears with the elders who hold it. Research reveals that Aboriginal astronomical observations were accurate, that traditional calendars were sophisticated, that the dismissal of Aboriginal science as superstition was itself the primitive position. The recognition comes late, after much has been lost, after generations of knowledge holders have died without passing on what they knew. But it comes. We stand in the imagined outback night, watching the emu emerge in the Milky Way's darkness, learning to see what Aboriginal astronomers have seen for 60,000 years. The sky is the same. The stars have shifted slightly. 60,000 years is enough time for proper motion to alter positions, but the patterns remain recognizable. The emu still runs through the heavens. The seven sisters still shine as the Pleiades. The dreaming tracks still cross the sky as they cross the land. The darkness between stars where ancestors walked, where patterns emerged not from connection, but from absence, where the longest continuous astronomical tradition watched the same sky we watch and saw meaning. We are only beginning to understand. Australia, the emu, the darkness that speaks as loudly as light, forever watching, forever teaching, forever maintaining knowledge that nearly vanished, but survives still in elders who remember and in the sky that does not forget. In 1960, near the German town of Nebra in Saxony-Anhalt, treasure hunters using metal detectors discovered objects that would rewrite the history of Bronze Age Europe. In a prehistoric enclosure atop a hill called Mittelberg, they found two bronze swords, two axes, a chisel, fragments of spiral arm rings, and a circular bronze disc approximately 12 inches in diameter, covered with gold symbols representing what appeared to be the sun, the moon, and stars. The Nebra sky disk, as it came to be called, was not only beautiful, it was impossible. It was a realistic representation of the night sky, the oldest known in the world, created around 1600 BC by people who left no written records and whose astronomical knowledge we had vastly underestimated. The disk's authenticity was initially questioned. Nothing like it had ever been found. The sophistication seemed too great for Bronze Age Europe, which had left no evidence of such astronomical interest, but scientific analysis confirmed what seemed unbelievable. The bronze was consistent with Bronze Age metallurgy. The gold came from different sources, suggesting the disk was modified over time. The patina was genuinely ancient. The Nibra sky disk was real. The astronomical knowledge it represented was real, and everything we thought we knew about Bronze Age European astronomy required revision. The disk depicts the sun or full moon as a large gold circle, another gold circle representing either the moon or the sun depending on interpretation, and a cluster of gold dots arranged in a pattern that corresponds to the Pleiades. Additional dots scattered across the surface may represent other stars or may be decorative. The interpretation remains debated. Two curved gold bands along the edges, added later, mark the angle between summer and winter solstice sunrise positions, approximately 82 degrees at the latitude of Nebra. A curved arc at the bottom, also added later, may represent the sun boat of Egyptian mythology, suggesting contact with Mediterranean cultures, or may represent a rainbow, or may carry meaning now entirely lost. The Pleiades cluster is significant. In many cultures, the Pleiades served as agricultural markers. Their heliacal rising, first appearance before dawn, signaled planting time. Their setting marked harvest. The cluster's prominent position on the disk suggests that Bronze Age Europeans tracked celestial events for practical agricultural purposes, that they had developed notation systems to record astronomical observations, that they possessed knowledge systematic enough to be encoded on portable objects. The disk may have been a calendar, an agricultural guide, a ritual object, a combination of all these, or something our categories cannot contain. The solstice arcs are perhaps most remarkable. To know the angle between summer and winter solstice sunrise positions requires careful observation over at least a full year, requires understanding that the sun rises at different points on the horizon throughout the year, requires the concept of solstice itself, the understanding that the sun's position on the horizon reaches limits beyond which it does not go, then turns back. This is not casual observation. This is systematic astronomy, knowledge that requires intention, method, and transmission across time. The disk was modified over its period of use. Additional elements added to an original that already carried astronomical meaning. The modifications suggest that the disk was important, was used, was refined as knowledge developed or as purposes changed. The disk was not static object, but was living document, updated across generations, carrying accumulated understanding rather than single moment's insight. The burial is equally mysterious. Around 1600 BC, the disk was deposited in the prehistoric enclosure on Mittelberg, along with the bronze weapons and ornaments found with it. Why bury such knowledge? Was the disk hidden for safekeeping during conflict? Was it ritually decommissioned, its power deliberately returned to earth? Was it an offering to gods who dwelt in the soil? The burial preserved what might otherwise have been lost. Bronze corrodes. Objects are recycled. Only deliberate interment protected the disk across millennia. But the intention behind the burial remains unknown. The disk has no context. No written records describe its creation or use. No other objects like it have been found that might reveal the culture that produced it. The disk appears alone, unprecedented, testimony to astronomical knowledge that existed in Bronze Age Europe and that vanished, leaving only the single artifact as evidence. The silence around the disk makes its existence more remarkable and more frustrating. We have the object, we have nothing else. We contemplate the disk in its museum case, gold still gleaming after 3,600 years. the Pleiades still recognizable to any modern eye that looks up in November when the cluster rises, the hands that shaped this bronze, that inlaid this gold, that aligned these symbols to celestial positions, those hands are dust, their names are lost, their culture left no other trace of such astronomical interest. The disk speaks of knowledge we did not expect, tradition we cannot trace, understanding that existed and vanished, and left only this single window into Bronze Age sky watching, the disk that fell from a forgotten heaven, that preserved what oral tradition could not preserve, that testified to astronomical knowledge that exceeded our expectations. Nebra, the sky disk, forever waiting to be understood, forever testimony to how much we do not know about how much ancient peoples knew. In the library at Alexandria, around the year 240 BC, a man named Eratosthenes performed a calculation that seems impossible for his time. He was the chief librarian, a scholar of wide ranging interests who wrote on mathematics, geography, poetry, and philosophy. He had heard about a well in the city of Syene at the southern edge of Egypt, where at noon on the summer solstice, the sun shone directly down the shaft, indicating that the sun was directly overhead, casting no shadow. In Alexandria, several hundred miles to the north, the sun at the same moment was not directly overhead. A stick planted vertically cast a shadow at an angle of approximately 7 degrees. From these two observations, Eratosthenes calculated the circumference of the earth. The logic was elegant. If the earth were flat, the sun would be at the same angle everywhere at the same moment. The fact that shadows differed between Syene and Alexandria meant the earth's surface was curved. The angle of the shadow at Alexandria, approximately 1/50th of a full circle, meant that the distance between the two cities was approximately 1/50th of the earth's circumference. Eratosthenes knew the distance between Syene and Alexandria, approximately 5,000 stadia. The exact length of a stadion remains uncertain, but it was probably around 157 meters. Multiplying, he obtained a circumference of approximately 250,000 stadia, equivalent to roughly 39,000 to 46,000 kilometers, depending on which value of stadion we use. The modern measured circumference of the Earth is approximately 75 kilometers. Eratosthenes was accurate to within a few percent, using only a stick, a well, the knowledge of distance between two cities, and reasoning. The achievement deserves contemplation. No satellites, no computers, no precision instruments beyond what a careful observer could construct. Only the recognition that shadows differ depending on location, that this difference must have a cause, that the cause must be the curvature of the earth, that the curvature could be measured through geometry. The leap from observation to conclusion required understanding that the earth was spherical, not a universal belief in the ancient world, though educated Greeks had accepted it for centuries, and understanding that the sun's rays arrived at earth essentially parallel, so that differences in shadow angle reflected differences in surface angle, not differences in the sun's position. Eratosthenes worked in a context that made such calculation possible. Alexandria's great library was the intellectual center of the Hellenistic world, a place where scholars from across the Mediterranean gathered, where texts in every language were collected, where the ambition was nothing less than preserving all human knowledge. The library was supported by the Ptolemaic rulers of Egypt, who understood that patronizing scholarship enhanced their prestige and attracted the best minds to their capital. Eratosthenes was not an isolated genius, but was a scholar working within an institution that valued and supported systematic inquiry. The library enabled accumulation. Eratosthenes built on earlier work, on Greek mathematics developed over centuries, on geographical knowledge compiled by earlier scholars, on the philosophical tradition that encouraged rational explanation of natural phenomena. He had access to texts from across the ancient world, could consult Egyptian astronomical records, Babylonian mathematical tablets, Greek philosophical treatises. The calculation that measured the earth was possible because the library made the necessary knowledge available in one place, allowed one scholar to synthesize what many cultures had developed. But the library was also fragile. It would burn, whether in single conflagration or through centuries of neglect and destruction, and much of what it contained would be lost. Eratosthenes' calculation survived because it was remarkable enough to be recorded by later writers, but most of his work is lost. We have titles and fragments, references and summaries, but the original texts are gone. The library that enabled the calculation also demonstrates knowledge's fragility. What one generation gathers, subsequent generations can scatter. The well at Syene still exists. The sun still shines directly down the shaft at noon on summer solstice. The shadow at Alexandria still falls at the same angle it fell when Eratosthenes measured it. The geometry has not changed. The earth has not changed. Only human understanding has waxed and waned, has discovered and forgotten and rediscovered, has achieved insights that were then lost and had to be regained centuries later. We stand in the imagined library, surrounded by scrolls that have mostly vanished, watching a scholar contemplate shadow and distance and arrive at understanding that would not be surpassed for nearly 2,000 years. The moment is pivot point, the moment when observation became measurement, when the earth could be held in human understanding, when the cosmos shrank to something that could be calculated. The well at Syene captured sunlight. The stick at Alexandria cast shadow, and in the space between, human reason measured the world. The well that measured the world. The shadow that revealed the earth's curve. The calculation that demonstrated what human intelligence could achieve when given tools and time and freedom to think. Alexandria, Eratosthenes, the library that preserved knowledge until it burned. Forever testimony to what can be accomplished. and to what can be lost when the institutions that support knowledge fail. In the spring of 1901, Greek sponge divers, working off the coast of the small island of Antikythera, between Crete and the Peloponnese, discovered an ancient shipwreck. Among the marble statues, bronze figurines, and luxury goods scattered across the sea floor, they recovered an unremarkable looking lump of corroded bronze. It was set aside, catalogued, largely ignored, as attention focused on the more obviously valuable artifacts. Only decades later, when researchers began examining the corroded mass more carefully, did they realize that the lump contained gears, precisely cut bronze gears, arranged in complex mechanism, representing technology that should not have existed in the ancient world. The Antikythera mechanism, as it came to be called, has been studied continuously since the 1950s, each new imaging technology revealing additional complexity. The current understanding identifies at least 30 gears, including a differential gear previously thought to have been invented in the 18th century. The mechanism was designed to predict solar and lunar eclipses, to track the positions of the 5 planets known to antiquity, to calculate the dates of Olympic Games and other recurring events. It was, in essence, a mechanical computer, an astronomical calculator that could model celestial motions with accuracy that would not be matched for over 1,000 years. The mechanism dates to approximately 100 BCE, perhaps a few decades earlier, based on the astronomical positions encoded in its gears. It was found in a ship carrying Greek luxury goods westward, perhaps toward Rome, lost in a storm that preserved what normal maritime trade would have delivered, and eventually discarded. The shipwreck is accident. The preservation is accident. Our possession of this impossible object results from the same chance that destroyed countless other ancient artifacts. How many similar mechanisms were made? How many existed and vanished without trace? The questions cannot be answered. We have only this one, this single window into an astronomical tradition sophisticated beyond expectation. The front face of the mechanism displayed the positions of the sun and moon in the zodiac, the phase of the moon, and possibly the positions of the 5 known planets. The back face displayed 2 complex spiral dial systems, one tracking the metonic cycle, the 19-year period after which lunar phases repeat on the same dates, the other tracking the Saros cycle, the 18-year period after which eclipses repeat in similar patterns. The mechanism could predict when eclipses would occur, could indicate which eclipses would be visible from which locations, could provide the kind of foreknowledge that ancient peoples valued enormously and that normally required human astronomers watching the sky continuously for generations. But who made it? The question haunts the mechanism. No ancient source describes such a device. No other examples have been found. The inscriptions on the mechanism, tiny Greek text describing its functions, suggest it was made for Greek speaking users, possibly in the Corinthian colonies of Sicily. Some scholars connect it to Archimedes, the famous mathematician who was killed when Rome conquered Syracuse in 212 BCE. Cicero, writing in the 1st century BCE, describes mechanical devices made by Archimedes that could model the motions of the heavens. But the connection remains speculative. The mechanism's maker is anonymous, its tradition untraced, its technology apparently unique. The complexity suggests context. No single genius creates such a mechanism without predecessors, without a tradition of working with bronze gears, without astronomical knowledge accumulated over generations. The Antikythera mechanism implies an entire tradition of mechanical astronomy that existed and vanished, that produced devices of which only this one survives, that represented knowledge lost when the ancient world gave way to medieval. The mechanism's isolation makes it more remarkable and more troubling. Where are the others? Who made them? What happened to the tradition that enabled such achievements? The mechanism was created in a world where astronomical knowledge was valued, where predicting celestial events had religious and political significance, where rulers and priests wanted to know what the heavens would do before the heavens did it. The ability to predict eclipses was power. It demonstrated understanding that ordinary people did not possess. It proved that the predictor had special connection to cosmic order. It legitimized authority through knowledge. The mechanism may have been made for a temple, for a wealthy patron, for someone who wanted portable astronomical capability, the ability to make predictions without maintaining a staff of astronomers watching the sky. We contemplate the mechanism in its museum case. Gears frozen in corrosion, knowledge encoded in bronze teeth that will never turn again. The ship that carried it sank 2,000 years ago. The person who owned it, the purpose for which it was intended, the use to which it would have been put, all this is lost in the Mediterranean's depths. We have the mechanism. We understand how it worked, but we do not understand how it came to exist. What tradition produced it? What became of that tradition when the ancient world ended? The gears that predicted the heavens, that calculated what astronomers would otherwise have observed, that demonstrated capability we did not expect from the ancient world. Antikythera, the mechanism, forever mysterious, forever testimony to how much was lost when the ancient traditions ended, how much we cannot recover despite all our analytical tools, how much knowledge existed and vanished, leaving only this single, impossible artifact as evidence. In the Boyne Valley of Ireland, where the river curves through green fields and mist rises from the water on cold mornings, there is a mound that has been waiting for 5,000 years. New Grange was built around 3200 BCE, making it older than Stonehenge, older than the Egyptian pyramids, older than any other known architectural structure aligned to astronomical events. The mound is massive, over 250 feet in diameter, rising nearly 40 feet above the surrounding landscape, covered with white quartz stones that would have gleamed in sunlight, creating an artificial mountain visible for miles across the ancient landscape. But the true wonder lies inside. A narrow passage extends nearly 60 feet into the heart of the mound, leading to a cruciform chamber with carved stone basins that once held the cremated remains of the dead. For most of the year, the passage is entirely dark. No natural light penetrates to the chamber, which rests in perpetual night beneath tons of stone and earth. But for approximately 17 minutes, around the winter solstice, something extraordinary happens. Above the passage entrance is a structure called the roof box, a narrow opening in the stonework, separate from the main entrance, designed to capture a specific beam of light. As the sun rises on the mornings around the winter solstice, a thin ray of sunlight enters the roof box, travels down the passage, and illuminates the chamber at the heart of the mound. For 17 minutes, the innermost darkness is filled with golden light. Then the sun rises higher, the angle changes, and the passage returns to darkness for another year. The precision required to achieve this effect is extraordinary. The builders had to know the exact position of the winter solstice sunrise, had to construct a passage that aligned to that position, had to create a roof box that would capture only that specific light while excluding light at other times. The alignment has held for 5,000 years. The slight shift in Earth's axis over that time has moved the light off perfect center, but it still enters, still illuminates, still does what it was designed to do. The builders calculated for permanence and achieved it. But what did it mean? This question haunts Newgrange, as it haunts every prehistoric astronomical monument. The cremated remains found in the chamber suggest that Newgrange was a tomb, a place where the honored dead were brought to rest beneath the mound's mass. The solstice light entering the chamber may have been understood as the sun visiting the dead, as light returning to those who had entered the darkness of death, as connection between the living world of light and the eternal world of the departed. The symbolism speaks across millennia, light penetrating darkness, warmth entering cold, life touching death at the year's deepest point of darkness. The winter solstice is the longest night, the time when the sun is weakest, the moment when darkness seems to triumph over light, but it is also the turning point. After the solstice, days begin to lengthen, light begins to return. The sun begins its journey back from its southern extreme. To capture the solstice sunrise was to capture the moment of turning, the moment when the cosmos shifted from waning to waxing, the moment of renewal that promised that spring would come again. The people who built Newgrange left no written records. Their language is unknown. Their religious beliefs can only be inferred from the monuments they left behind. But they cared enough about the winter solstice to invest extraordinary labor in capturing its light, quarrying and transporting the massive stones, constructing the passage with sufficient precision to maintain alignment across millennia, decorating the stones with spiral and lozenge patterns whose meanings are now lost. The monument was not practical. It did not provide food or shelter or defense. It served purposes that we would call spiritual or religious or sacred, purposes that mattered enough to justify the effort required. The Boyne Valley contains other mounds, Noth and Douth, both similarly massive, both containing passages aligned to celestial events. Noth's passages align to the equinoxes. The valley was not a single monument, but was a sacred landscape, a place where astronomical alignments were accumulated over centuries, where different aspects of the solar cycle were captured in different structures. The people who built these monuments were not isolated groups, but were part of a culture that valued astronomical knowledge, that transmitted the skills and intentions necessary to build such monuments across generations. We stand in the imagined passage as solstice light enters for the first time in a year. The beam travels slowly down the corridor, illuminating carved stones that have waited in darkness, reaching the chamber where the dead once rested, bringing warmth to the cold heart of the mound. For 17 minutes, the darkness is broken. Then the light retreats, the sun rises higher, and the passage returns to the darkness that is its normal state. The passage that swallowed winter sunlight, that captured the moment of cosmic turning, that joined the living and the dead in celebration of light's return. New Grange, forever aligned to the solstice, forever receiving the light that was designed to enter it, forever testimony to people who understood the sky well enough to build monuments that would capture its rhythms for generations they could not imagine. In the high Andes of Peru, where the air is thin and the stars burn with cold intensity, where the Inca built an empire that stretched 3,000 miles along the spine of the mountains. Sacred stones rise from sacred rock at places where the earth and sky were believed to meet. The Intihuatana at Machu Picchu is one such stone, a carved granite pillar rising from a carefully shaped base positioned at the highest point of the citadel, designed to serve purposes both astronomical and ritual. The name translates to hitching post of the sun, and in this phrase lies understanding that differs fundamentally from Western astronomy. The Inca did not merely observe the sun, they participated in its journey. They believed that at the solstices, when the sun reached its extreme positions and began to return, the sun needed to be ritually tethered to the earth to prevent it from wandering away entirely. The Intihuatana stones were the posts to which the sun was tied. The priests who performed the rituals were not passive observers, but active participants in cosmic maintenance, responsible for ensuring that the sun continued its journey and the seasons continued their cycle. Astronomy was not study, but was ceremony, not observation, but ritual action. The Intihuatana at Machu Picchu is carved from the living bedrock of the mountain, shaped but not separated from the earth itself. The pillar rises from a complex base whose angles align to astronomical events. The corners point to the cardinal directions. The angles of the faces correspond to the angles of sunrise and sunset at significant times of the year. The stone is positioned so that at the spring and fall equinoxes, the sun stands almost directly above the pillar, casting no shadow at midday. At the solstices, the shadow falls at precisely calculated angles. The stone is instrument and altar combined, observatory and temple unified in a single sacred object. The Spanish destroyed most Intihuatana stones, recognizing them as centers of indigenous religion, removing the physical objects that focused Inca worship. The Intihuatana at Machu Picchu survived only because the Spanish never found Machu Picchu. The city was abandoned sometime after the conquest, its location forgotten until Hiram Bingham stumbled upon it in 1911. The stone remains intact, one of the few surviving examples of Inca astronomical architecture, testimony to a tradition of sky watching that differed profoundly from European approaches. The Inca astronomical tradition extended far beyond the Intihuatanas. From the capital at Cusco, imaginary lines called seques radiated outward in all directions, connecting hundreds of sacred sites called huacas. Some huacas were natural features, mountains, springs, unusual rock formations. Others were constructed, temples, platforms, stones shaped by human hands. The sequus created a sacred geography that was also an astronomical geography. Many seques aligned to horizon positions where the sun or stars rose at significant times. The system connected geography and astronomy, transformed the entire landscape into an instrument for reading the sky. The quipus, the knotted strings that served as Inca recording system, may have encoded astronomical information, though the exact content of most quipus remains undeciphered. We know the Inca tracked lunar phases, predicted eclipses, observed Venus and the Pleiades, developed calendars sophisticated enough to time agricultural activities across an empire that stretched through multiple climate zones. But without writing in our sense, the details of Inca astronomical knowledge survive only partially, recorded by Spanish chroniclers who understood some things, misunderstood others, and failed to ask questions we would want answered. The sun worship that the Intihuatana served was central to Inca religion. The emperor was considered the son of the sun, his authority derived from celestial parentage. The festival of the sun, Inti Raymi, was the most important celebration of the Inca year, held at the winter solstice, which is in June in the southern hemisphere, marking the moment when the sun was weakest and needed human support to begin its return. The priests who performed the rituals at the Intihuatana were ensuring that the cosmos continued to function, that the sun would return, that the agricultural cycle would continue, that the empire would prosper. We stand at the Intihuatana as the sun approaches its zenith, watching the shadow shrink toward nothing on the equinox day when light falls vertically and the pillar casts no shadow at all. The priests who tended this stone are gone. The rituals are forgotten. The empire that built Machu Picchu collapsed under Spanish conquest, but the stone remains, still aligned to the sun's positions, still marking the cosmic rhythms that the Inca believed required human participation to maintain. The stone that tied the sun to earth, that anchored the cosmos through ritual attention, that demonstrated understanding of astronomy as sacred responsibility rather than merely scientific observation. Intihuatana, the hitching post of the sun, forever waiting for priests who will never come, forever marking the sun's journey across a sky that no longer needs human tethering, forever testimony to a culture that watched the heavens not to understand, but to participate, not to study, but to serve. In the Valley of the Kings, where pharaohs were laid to rest in tombs carved deep into limestone cliffs, where treasure and tomb robbers have struggled for 3,000 years. The ceilings blaze with stars that have not moved since they were painted. The astronomical ceilings of Egyptian tombs are among the most beautiful and most mysterious astronomical records from the ancient world. Maps of a sky that no longer exists, catalogs of stars and constellations that have shifted with precession, records of celestial knowledge that served purposes both practical and sacred. The ceiling of the tomb of Setigue, who ruled from 1294 to 1279 BCE, is among the finest. Painted in deep blue with golden stars, the ceiling depicts the deacons, the 36 star groups that rise heliacally through the year, each ruling a 10-day period of the Egyptian calendar. The deacons were not merely markers of time, but were understood as deities, as divine beings who governed the hours of the night when the sun was absent from the sky. To paint them on a tomb ceiling was to surround the dead with divine presences to ensure that the proper gods attended each hour of the eternal night through which the deceased must pass. The astronomical ceilings served as star clocks. Without the sun to mark time during the night, Egyptians needed other methods to track the hours, to know when to perform rituals that required specific timing, to ensure that the dead had accurate celestial guidance for their journey through the underworld. The deacons rose in sequence through the night. Each deacon's appearance marked the beginning of a new hour. Each setting marked its end. The priests who watched the sky and the tombs that replicated it were connected by the same stars, the same celestial rhythm, the same divine beings moving through their appointed cycles. But the ceiling also served eschatological purposes. The Egyptian afterlife was understood as journey, as navigation through dangerous realms populated by demons and obstacles that the dead must overcome. The Book of the Dead, that collection of spells and prayers found in many tombs, provides instructions for this journey, what to say at each gate, how to address each deity, what words would ensure safe passage. The astronomical ceiling provided the map, showed the dead which stars to follow, which celestial beings to invoke, which heavenly paths led to the eternal fields where the justified dead would dwell forever. The ceiling of Senenmut's tomb, dating to around 1473 BC, is the earliest known astronomical ceiling and contains information precise enough that modern astronomers can date it to within a few years. The positions of planets and stars depicted on the ceiling correspond to a specific moment in time, a snapshot of the sky as it appeared when the tomb was decorated. This precision suggests that Egyptian astronomical observation was sophisticated, that positions were accurately recorded, that the astronomical content was not merely symbolic, but reflected actual celestial configurations. The circumpolar stars, the stars that never set, that circle the northern celestial pole continuously through the night, held special significance. The Egyptians called them the imperishable ones, recognizing that these stars, unlike others, never descended below the horizon, never entered the underworld, never died their nightly death. The pharaoh's soul aspired to join the imperishable ones, to become a star that never set, to achieve the immortality that the circumpolar stars displayed every night. The astronomical observation was religious aspiration. To watch the stars that never set was to contemplate the eternal life the pharaoh hoped to achieve. The sky goddess Nut arches across many astronomical ceilings, her body forming the vault of heaven, her limbs reaching to the horizons, her mouth swallowing the sun at evening and giving birth to it at dawn. The conception is both astronomical and mythological. The daily journey of the sun was understood as passage through the body of the goddess, death and rebirth enacted daily through celestial mechanics. The astronomical ceiling was not neutral map, but was body of deity, was sacred space, was dwelling of divine Epoing, who governed cosmic cycles. We contemplate the ceiling in tomb darkness, imagining the gold and blue as fresh as when they were painted, the stars still gleaming in torchlight, the deacons still marching through their endless procession. The pharaoh who is buried here has turned to dust. The priests who sealed the tomb have vanished. The civilization that created this ceiling has transformed beyond recognition, but the stars remain painted above, positioned as they were positioned 3,000 years ago, marking hours that no longer need marking, guiding souls that have long since completed whatever journey awaited them. The ceiling that held the night sky in eternal blue, that mapped the heavens for the dead to navigate, that turned tomb into cosmos and darkness into star-studded eternity. Egypt, the astronomical ceilings, forever watching over the departed, forever preserving a sky that has shifted with precession, that no longer exists as it was painted, that survives only in this underground chambers where the ancient astronomers left their records in pigment and gold. Conclusion: where starlight meets silence, the chronicles of the first astronomers close. We have walked among cave paintings that may record constellations, held bones carved with lunar counts, stood in stone circles aligned to solstices, followed desert lines that only gods could see. We have watched serpents descend in equinox shadow, learned to see the darkness between stars, examined a bronze disk that preserves a forgotten sky. We have calculated the Earth's circumference with shadow and geometry, marveled at gears that predicted eclipses before Rome rose, entered passages that swallow solstice light. We have tied the sun to mountain stones and navigated tombs by ceilings painted with eternal stars. What have we learned? That astronomy is humanity's oldest science, older than writing, older than cities, older than any institution we might name. That the impulse to watch the sky and record what is seen stretches back at least 30,000 years, possibly far longer. That peoples we have dismissed as primitive possessed knowledge that modern observers are only beginning to appreciate. That much was lost when ancient traditions ended, when libraries burned, when colonial powers destroyed what they did not understand, when the chain of transmission was broken, and knowledge that had accumulated across millennia vanished in generations. We have learned that ancient astronomers were not merely watching, they were participating. Were not passive observers, but active agents in what they understood as cosmic maintenance. The Inca tied the sun to stone. The Maya calculated when to act and when to wait. The Egyptians painted star maps for the dead to navigate. Astronomy was never separated from religion, never isolated from practical concerns, never abstract knowledge without application. To know the sky was to know when to plant, when to harvest, when to gather, when to perform rituals that ensured cosmic order continued. We have learned that astronomical knowledge served power, but also served humanity. The priests who predicted eclipses held authority that observation conferred. The rulers, whose tombs contained star maps, claimed cosmic legitimacy, but the same knowledge told ordinary people when to plant their crops, tracked cycles that governed daily life, provided frameworks for understanding existence in a cosmos that might otherwise have seemed chaotic and threatening. The solstice light entering Newgrange offered comfort, proof that the sun would return, that darkness was not permanent, that the cycles continued even when individual lives ended. We have learned how much we do not know. The Antikythera mechanism implies an entire tradition of which no other evidence survives. The Nebra sky disk appears without context, without predecessors, without successors. The Indus Valley script remains undeciphered. The astronomical knowledge of that civilization is locked in symbols we cannot read. The Aboriginal astronomical tradition nearly vanished under colonial persecution. What survives may be only a fraction of what existed. The losses are real, the gaps cannot be filled. We know the ancient astronomers achieved remarkable things, but we cannot recover all that they achieved. As sleep approaches, as consciousness dims toward dreams, we carry these mysteries with us. Carry the image of a Paleolithic painter recording the Pleiades in cave darkness. Carry the weight of stones aligned to solstices. Carry the wonder of gears calculating eclipses before Rome rose. Carry the sadness of traditions lost and knowledge vanished. Carry the recognition that we are part of a longer story, that humans have watched the sky and recorded what they saw for at least 30,000 years, that we inherit the accumulated efforts of countless observers whose names we do not know, but whose legacy we possess. The ancient astronomers left their records in stone and bone and bronze, in cave paintings and carved passages, in monuments aligned to celestial events and ceilings painted with eternal stars. Their questions were our questions. Their wonder was our wonder. Their need to understand patterns larger than themselves, to find their place in the cosmos, to record what they had learned so that others might learn. This is our need as well. Sleep well. Dream of ancient observers watching the same stars we watch, tracking the same moon that still governs tides and calendars, measuring the same sun that still rises and sets as it rose and set when the first astronomers turned their attention skyward. Dream of knowledge lost and knowledge preserved, of traditions ended and traditions continuing, of humanity's oldest science still practiced on the same planet, under the same skies, with the same stars that our ancestors watched 30,000 years ago. The sky maps carved in stone, the calendars counted in bone, the observatories aligned to celestial events, forever recording, forever speaking across millennia, forever connecting us to those who first looked up and wondered. The stars remain, the questions persist, and in the space between ancient observation and modern understanding, the first astronomers still watch, patient, precise, waiting for us to recognize what they already knew, that we are part of the cosmos, that the patterns above us shape the patterns around us, that to watch the sky is to participate in something larger than any individual life, something that was ancient when the first cities rose and will continue long after the last civilization falls. Good night. The ancient astronomers are with you still. The stars they watched are the stars you see. The knowledge they gathered flows through time to the present moment. Rest now, and remember, you too are a watcher of the sky, heir to 30,000 years of observation, part of the longest continuous human endeavor. The sky, the silence, the starlight that has traveled millions of years to reach your eyes, forever connecting, forever teaching, forever the same stars, the same wonder, the same endless human asking. Sleep. The cosmos will be there when you wake.